Hello and welcome back to my channel Learn with Nikhil. In this video, we'll see the MCQs on the topic transformations used in robotics. If you want to understand the MCQs, how the solution came, visit my video lectures on this topic. Link is given in the description below. So let's begin. First, which one of the following statements are false? To represent the position and orientation of a 3D object in 3D space, A. We need a set of 4 vectors. We need a 3 by 3 matrix. We can take the help of Cartesian coordinate system. Or D. We need a 4 by 4 matrix. And the answer is we need a 3 by 3 matrix. Next, homogeneous transformation matrix used in robot kinematics has the dimensions of 3 by 3, 4 by 4, 3 by 4 or 4 by 3. For homogeneous transformation matrix, we have a 4 by 4 matrix. Next, which of the following statements is false regarding rotation matrix? Each row or column of a rotation matrix is a unit vector. The inner dot product of each row of a rotation matrix with each other row becomes equal to 0. Inverse of a rotation matrix is nothing but a transpose, or rotation matrices are commutative in nature. So, this is a statement which is false. Rotation matrices are commutative in nature. According to the rule of composite rotation matrix, a rotation of alpha angle about z followed by a rotation of beta angle about y-axis followed by the rotation of gamma angle about x-axis is written as a rotational composite rotation of x, y, z, rotation composite rotation of y, x, z, rotation composite of y, z, x, and rotation composite of rotation about z, x, and y. So the rule of rotation of composite matrix is that this is the sequence given in the question, that alpha about z axis, beta about y, and gamma about x axis. So you have to write the composite matrix in opposite sequence. So first will come gamma about x axis, then beta about y axis, and alpha about z axis. So according to this is the right statement. So your answer is 1. Which of the following statements is true? The concept of roll, pitch, and yaw angles can be used to represent the position of end effector of a manipulator with respect to the base coordinate system, represent the orientation of end effector of a manipulator with respect to the base coordinate system, represent both position and orientation, represent neither the position nor the orientation. So the statement which is true is for roll, pitch, and yaw angles, represent the orientation of end effector of a manipulator with respect to its base coordinate system. Next, this is the question. A frame B is rotated x underscore u axis of the universal coordinate system by 45 degrees and translated along x universal coordinate, y universal coordinate, and z universal coordinate by 1, 2, 3 units respectively. Let the position of the point Q in B is given by 3, 2, and 1. Determine Q bar raised to U. So Q of the universal matrix. These are the options and this is the solution. Now, for referring this solution, you can visit my video lecture on this topic. I've given the link in the description below. Next question. This is the similar type of question to the previous one. You can solve it with the similar process. You can refer to the video lecture given in the description below. And here the right answer is 1.76, 3.8664. According to the Dennevit-Hartenberg notation, link and join parameters represent the relative position of neighboring links and structure of the link respectively, the structure of a link and relative positions of the neighboring links respectively, structure of the link only, or the relative positions of the neighboring links only. So according to the DH parameters, the answer is B. Next question. According to the DH notations, the length of the ith robotic link can have a positive value only, a negative value only, zero value only, either position or zero value. And the answer is either position or zero value. According to the DH notations for the revolute and prismatic joints, joint angle theta is considered as variable, link offset D is considered as variable, theta and D are considered variable, D and theta are considered as variables. So in DH notations for revolute and prismatic joints, theta and D both are considered as variables respectively. So theta for revolute and D for prismatic are considered as variables. Next, according to the DH notations, angle of the twist of the ith link is defined as the angle between two consecutive z-axis measured about x-axis, two consecutive x-axis measured about z-axis, two consecutive y-axis measured about x-axis, or two consecutive x-axis measured about y-axis. And the answer is two consecutive z-axis measured about x-axis. This is for the ith link. Next, according to the DH notation, joint angle theta is defined as the angle between two consecutive z-axis measured about x-axis. Same we have, and the answer is two consecutive x-axis measured about z-axis. That is the joint angle theta. Which of the following statements is true? Rotational of x theta 1, rotational of x theta 2 will be equal to the rotational of x theta 2, rotational of x theta 1, rotational of x theta 1, rotational of x theta 2 is equal to the minus rotation of x theta 2, rotation of x theta 1, rotation of x theta 1, rotation of x theta 2 will be equal to the rotation of x theta 1 plus theta 2, or rotation of x comma theta 1, rotation of x theta 2 is equal to rotation of x theta 1 minus theta 2. So the right answer, the notation is C. Similar question. In this, which the statement is true, that is the first one. So these are the equations of the laws of equations. You have to know each and every equation. Any question can be asked. Next, with joints J1, J2 and J3, the coordinate frames have been marked for you and the link length have been mentioned. What is the value of A1, A2 respectively? So this is the question given. So as you know, value of A1 and A2. So A1 and A2 is nothing but the length of the links. Anything can be asked with respect to the diagram. You can ask the alpha angles, you can be asked the theta angles, you can be asked the D, anything can be asked. So according to this diagram, what is the value of A1? A1 is nothing but the length of the link A1, that is 5, and A2 is nothing but the length of the link A2, that is this. So 5 comma 3 will be the answer. So you have 3 joints, you have 2 links, this is the end effector, you should be able to know. Answer is 5, 3. Similar question, but here you have been asked the values of D1 and D2. So D1 and D2 are nothing but the joint offsets, and here the joint offset is 0. As there is no movement, no length according to the joints, it is stable here. So that is 0, 0. Next, again similar type of question, but in this we have been asked alpha 1 and alpha 2 values. So alpha 1 and alpha 2 is nothing but the twist angles, and as you can see from the image, the z-axis is in one direction. So that means the twist angle will be 0, 0. If the z-axis was in opposite direction with respect to this, then the twist angle would have changed. Now as the z-axis is in one line, so the answer is 0, 0. Next, similar type of question, but the diagram is different. Here you have been asked the values of theta 1 and theta 2. You have 3 joints So you have theta 1, theta 2 and theta 3, but you have been asked theta 1 and theta 2. So according to this diagram, the values of theta 1 and theta 2 will be 90 degree and 90 degree. For much more explanation, you can visit my video lectures. It is given in the description below. You can check it out. Next, the degree of freedom of a rigid body in space is 3, 1, 6, 4, and the answer is 6. So for a rigid body, a three-dimensional body, the degree of freedom is 6. Next, if the workspace of a 3DOF manipulator is a cylinder, then its configuration is given by PPP, RRP, RPP, RRR. Now P means prismatic and R means rotational joint. So for a workspace of a 3DOF manipulator cylinder, its configuration is 1 rotation and 2 prismatic joints. So RPP. What is the transformation matrix if trans x comma q? So if the translation matrix, if it is moving in x direction for q units, then its matrix will be either this, this, this or this. And the right answer for x moving in x direction q units, the transformation matrix will be q here. So this is the right answer. If it was y, then here z, then it would have been here. So the right answer is A. Similar question. Now here you have been given y. So as I told earlier, here it is y. So it is moving in y direction q units. So this is the transformation matrix. And the final z. So this is the transformation matrix. If it is moving in z direction for q units, this is the transformation matrix. Now same, given the rotational matrix. Now for the rotation matrix, if it is rotating about z axis at an angle of theta, this is the rotation matrix. This is the 3x3 rotation matrix. Same if it was in x direction, then this is the rotation matrix for x direction. And finally, for y direction, this is the rotation matrix for y direction. Next question. Frame translation matrix used in robot kinematics has the dimensions of 3 into 3, 1 into 1, 3 into 1 or 1 into 3. So translation matrix is nothing but a matrix of 3 into 1. Same for the frame rotational matrix. The dimensions of a matrix are 3 into 3. Next question. What would be the values of alpha 1 and alpha 2 for the given figure? Same figure as we have seen previously, but the values of alpha 1 and alpha 2 is 90 degrees and 0 degrees. So alpha 1 is 90 degree and alpha 2 is 0 degrees. For explanation, you can visit the video and see the whole explanation. Similar question with similar figure, but here you have been asked the values of A2 and A3. So A is nothing but the length of the link. So you have 3 links. This is the first link, second link and third link. Don't confuse with this distance. This is nothing but the joint offset link, that is D. So this 2 units is that. So this is the first link, this is A1, this is A2 and this is A3. So according to this, we have been asked A2 and A3. So A2 is 3 units, so it will be 0.3 and A3 is 1 unit, that is 0.1. So this is, our right answer is B. Next, similar question, but the image is different. Here you have been asked the values of alpha 1 and alpha 2, and the values of alpha 1 and alpha 2 is 90 degree and 90 degree. In DH parameters, theta symbol is denoted for joint offset, joint angle, link length or twist angle, and the right answer is joint angle. Same in DH parameters, alpha is denoted for twist angle. B or D, in some books it is given B, in some it is given D. It is denoted for joint offset. And finally, A is denoted for link length.